谢谢你们欢迎我。I'll give a brief introduction of who I am. 要是常常我用中文讲话，可是 most of the time the talk will be in English. But 我有一个好朋友在那边，我们一起给这个 presentation 好吗？好。所以我做这个 presentation 的时候 ，at the end.Whoever asks the best question is gonna get a present. 一个礼物。好，这个是一个秘密，所以我不说哪一个礼物。But just a brief background on who I am. 我叫潘迪文，我工作在 Facebook on a software called M. M 是a personal assistant for Messenger. So you can ask it for questions.Saying something like, "Oh, 我很饿，我要一个吃的东西。"我们的 artificial intelligence 可以知道你说什么，给你吃的东西。所以 the topic I want to talk to you about today is called universal applications. And if you haven't heard about universal applications, you could have been heard about isomorphic application. Now, if we search for isomorphism, though, 我们看这个 description 是 bijective morphism。我是英国人，我不知道他这个说什么。
这个叫
我们不是 scientists, so we can call it something easy to understand, like universal applications. Okay. And to really feel the pain that universal applications are solving, I'm going to go and take us back in time. 好了 ，2015, 14, 13, 12, 11.10. Boom, 到了 the year of Coldplay and Rails 2.2.2. And so during this time of the way that we built applications, if we were to look at how our applications were built, we would see something like this. So you would ask, where is the JavaScript in this files, right? Is it here? 不是 Is it here? Kind of. 是在这里 Right? In a very, very small, 小小的 area. 他们加一个 s, 因为你可以用就是一个 JavaScript file, 所以他们要说 JavaScript 是要是你有打一个 So, this is how our applications were built at the time. And if you were to dissect our application, if you were to look at what was on the front end and what was on the back end, you would see something like this. So you would see that routing, validation, and views is on the server. So what's on the front end, right? 我们只有 cool animations. In some browsers, not even all the browsers, just some. 几个 browsers. So if we looked at our applications at the time, 我们的 front end code 看起来这样的 document, ready, function, welcome screen, hello animation. 全部的 code 在 Ruby. But now let's move forward in time a little bit. We'll reverse the 这个 GIF. 所以 2009, 2010, the year of Justin Bieber. And the year of Backbone, 0.1.0. So around 2010, maybe even earlier, applications were getting more and more complex. And if you wanted to deliver a web app that was just as good as a desktop application, you couldn't afford to refresh the page every single time anymore. So now if you looked at the application on the front end, this is how a Backbone app would have looked like. You're starting to see that you already have collections, models, and views mimicking what you're already having in Rails. So now we would ask, so this complexity is increasing and increasing. Backbone 以后我们有 Angular, 我们有 Ember, 我们有 Ember 2, 我们有 Bang Boom, like 什么都有. And you would ask, like, let's just see how many applications exist today on telling you how to build a to-do app, a to-do app. Right? So in order to manage this complexity, we're increasing the number of different frameworks that we're using. And now if you were to look at our applications, you would start to see JavaScript 有什么 routing, validation, and views. 可是 Rails 呢？ Routing, validation, and views. We're still doing that. We're just copying the same thing. So we have to ask the question, right? And then we start. We say, look, okay, well, you show that HTML is slim. It's just the way that you would write templates in Rails. Then you would make another one. You would say show.jst.ejs, which is the way you would write a template in JavaScript. And you think at first, okay, well, could you manage the complexity, right? You say, it's a little bit difficult, but I can make it happen, right? That's what happens. Boom, it goes too crazy, right? You start saying, well, okay, I'll just make an AJAX request here and there to get, if you want to do errors on the front end, it's okay, I'll ask. But then, you want to do optimistic updates, and you start repeating yourself, and it just gets extremely complex. So the question we want to ask, is it just the way things are? Is it irreconcilable that the front end and the back end need to have different pieces of code, that they're just inherently different things? So let's consider it, right? What if we had JavaScript in the front end and we have Rails in the back end? What if we did this? Bam! Just ate it. Node is just as fast, and it's getting faster and faster. Could we have a back end in JavaScript, and then we can share our routing, we can share our validation, and we can share our views? Would it be possible if we were able to do this? Well, you would ask, though, you would say, oh, Pandiwen. Well, the front-end technology looks something like this. I append to the DOM. I use the DOM all the time. And there's no such thing as the DOM in the back end. So what would I be really sharing? Well, we could kind of fix this, right? The big problem there is that we're writing imperatively. We're expecting, and we're making step-by-step instructions on how we want our UI to look like. What if we were to make a virtual representation of a DOM? So we would just say what the DOM should look like, and then something could figure out how to make those mutations. Well, when you React, that's it. We built that, right? And if we're able to do this, if we can declaratively define how we want our UI to look and then share the code, what are the wins that we would get? So what's the biggest win? The biggest win is code sharing. You can imagine your engineers being able to move between your applications with most of the code shared with the same language, no barriers that translate camel case to underscore to camel case. You're just using the same code. No repetitions. Now, the second one you'd get is perceived performance improvements, right? Before, if you wanted to show a single-page application, you'd have to load all the JavaScript before the user could see anything. They would just see a white page. Now, if you're sharing the code and your server is in JavaScript, you can just go and pre-render most of the UI that the user needs to see. The user can see it, and by the time he clicks anything, the JavaScript can be loaded on the page. And win 3 is SEO. So Google 说了，我们知道怎么看 single-page applications. And I'm sure Baidu has also said the same thing. But I don't think that that's true right now. Empirically, they're just not able to do it. So if you're able to pre-render most of your code, then you can be much friendlier for SEO. Well, let's see. Could we actually go and build this? Okay. So could we go and build this? Could we just show you now how to make this type of application? 你们准备了吗? Let's see what we can do. Okay, 准备了吗? Okay. So 我们有一个新的the Express app. Express is just a simple server in Node.js. And all we're doing here is we're just taking the parameters, and for anything that we get, we're going to go and return the string hello. 好了. So 要是我们写这个 code, 我们有什么? Nice. So 我们有一个 hello, 对不对? But you'll notice something. This hello is just a string hello. It's not HTML. Right? We don't have a title, we don't have a body, we don't have anything. 所以我们可以做一个 一个 template. So we can say, we could use a template language like handlebars to create our own template, but we don't really need to. We could just use JavaScript's template strings. And we're going to say we're going to take in a body and then return back this HTML string so that the client can have valid HTML. 对，所以我们做这个 template, and we'll see what we get. So now we have a template and it's just returning back hello. Let's start to use React. So we're just going to create a new component, and we're going to, in the render method, return back something that just says Stepan's blog. So you got h2 element. So now, instead of returning back hello, we're going to use render to string that comes with React. And because React is a virtual DOM, we can tell it, after you've computed what the DOM should be, you can either create DOM nodes or you can return a string that we can transfer through the pipe. So if we just go ahead now and say render to string, the app that we just created, what's going to happen? Okay, so you can imagine what would have happened is if you render that to string, you would just see the application, right? But now what if we add an on-click handler on this component? So we can now see, we click, but nothing happens because we don't have, the JavaScript doesn't actually land, right? We're just sending back what React thought from the server, but we have nothing on the client so far. Sad face. So let's go ahead and fix that. So we had this template before like this, right? Now what we want to do is we also want to load the JavaScript from the front end. So what we can do is we can add a new script tag and say whenever this page loads, request a client. And we're also going to wrap whatever the body is in a root div so the client can use that to take over the page. First, we'll render this. Then client.js is going to go and attach on the root node. So now we can go and create our client.js file. And we'll see that all we're going to do is we're going to import React. We're going to import React DOM. And then we're going to render the same app component onto the root div, onto the root element. Wow. So what just happened was we pre-rendered from the server. We loaded it onto the page. Then the client file overtook the root node and then added the right event handlers so that when we clicked it, this alert showed up. All up. So now we have the views shared, right? And essentially React is rendering both on the server and on the client. But what are the trade-offs? What's the catch over here? Is there any? Yes. So there is a bit of a catch. So when you write JSX, it just doesn't work out of the box in Node, right? Also, when you're using ES 2015, Node doesn't support the same type of importing. You might have to do module exports in Node and import in JavaScript. So in order to avoid that, what you can do is you can just do the build system for your front end and the back end with the same tooling. So you would have to add Webpack, you would have to add Babel, and you'd have to add a family of other tools. There is a small trade-off here, but once you've gone ahead and invested it, all of your engineers can use essentially see no difference between the code. So I think it's definitely a worthy investment. Now we've built an app, and it just returns a hello world, right? It just says, hello, welcome to my blog. That's not how a normal full-page application looks like and works like. One of the biggest next steps that we're going to have to do is to add routing. And this is where stuff starts to repeat itself. You have routing on the front end and routing on the back end. So on the front end, you would traditionally use window.location.pathname and add a switch case so that you'd be able to know what view you want to render. But the back end doesn't have window.location.pathname. So what we can do to abstract this away is to use a library that can help us do this. So the most often used one in React is called React Router. And what's that going to help us do is on the front end, it's going to take over and use push state and browser history to be able to do the routing. And on the back end, we're going to go ahead and just use a matching function to know what properties we need to do, what components we need to render on the first load. OK, so in order to make routing work, this is how our server looks before. we're just going to go ahead and we're going to disable server-side rendering for now. Right now, we have this render to string. We're just going to go ahead and return nothing for now and make routing work on the client. So this is how our app looked like before. We just returned this H2 element. Now we're going to get a little bit more complex. Wow. 我有一个真的大大的 app. 我们有一个 header, we have an about page, and we have a contact page. So this is how your app would start to grow, right? You'd have different pages. And now we're just going to go and define a new routes file. And what this is going to say is, this is the way you can use React Router to say declaratively how your route config is. We're going to say that on the root node, we're going to render the app page or the app component. In the index route, we're going to show the about page as the child. And in the case that the path is /contact, we're going to show the contact component. Now we have the client.js file, and we used to just return app. Instead, we'll go ahead and import routes. And we're going to use two things from React Router. We're going to use the router component and browser history, which is going to help us use the push state API on the client. So what will happen if we do this? OK, we have routing on the client, right? But what if we disable JavaScript? Will this still continue to work? Nothing. It just doesn't work, right? Because we didn't implement routing on the back end, and we had it disabled for now. So let's go ahead and implement it on the back end. So here's how our app used to look like, right? We had it disabled. We had server rendering disabled. Now we're going to go ahead and we're going to try to fix it. So we're going to import match router context from React Router, and we're going to import the same routes file that we were using in the client. So match is just going to take in a location, which is going to be a string, and then it's going to go ahead and try to find, either it's going to give you a function that returns an error or redirect, or the props you need to render this component. And then router context is just the low-level router API or the router component that we can use on the back end that doesn't attach to many of the client-side things that the normal router component uses. So we're moving pages, but JavaScript is disabled. So that routing is happening from the back end. Now we've built an app, and it has routing, it has server-side rendering. What's next? Like how does an app continue to grow? Well, usually apps that are complex start to use stores. In React, the way that we essentially store data outside of the app to make it much easier to write the components. I'm not going to get too deeply into how to use stores, because Shiqi, or one of my coworkers, is going to talk about the way that we do it at Facebook in a few hours. I am going to show you how we can make stores work both in the front end and the back end. So the way we can make stores work is we're going to import createStore, which is a function that's going to take initial data and it's going to create an event emitter, which React can connect to and then update whenever the data changes. And we're going to import provider, which comes from React Redux. So createStore, we can just do something like this. Store is equal to createStore. So now we'll use provider, which comes from React Redux. And what provider will do is it'll take in the store and then hook it up for our component. So whenever the store changes, the component will start to re-render. So now we do this in the client, but how are we going to do the same thing on the back end? Well, this is how our back end used to look like, our server.js. We're going to go ahead and we're going to start to do essentially the exact same thing. We're going to create a new store, and we're going to hook up a provider that provides the store. So notice, though, that the store is inside of the GET request, not outside. Because if it was, it would start to go past requests, right? We want to make sure that it only lives for one request. We create a store, we provide what we need, and then we end the store. OK, so now we have a store connected, but we probably want to have initial data, right? Initial data na? Because if you're on the server, we can technically get the data much faster than than you can if you're on a mobile device or on a slower internet connection. We're also much closer to the places where the data is at. So how can we go and do this? createStore takes an argument, right? createStore takes an argument for the initial data. What we could do is this. we just pass in the initial data that we need. So what will happen if we do this now? Well, underscore underscore data 不是 magical keyword, right? This doesn't exist right now. We're going to have to somehow define it. One thing we could do is we have this template function that takes in a body. What if we could also make it take in the data? Right. So we're just going to go ahead and we're going to add window.underscore underscore data. And then the way we could provide this data is we could have this function called fetch all data, and it would take in the properties that we have, and then we would pass it in to the template. So fetch all data would return back all the data we needed. So we now have data getting passed in to the client, and we have data on the server. But how do we do data fetching? 所以要是你没有 data fetching, 你为什么要一个 single page application, 对不对? So we're going to go ahead and we're going to try to implement data fetching. The first thing to realize about data fetching is that, can you do this in Node? Can you say $.ajax? No, we can't, because XML HTTP response is not going to be available in Node. But what we can do is we can start to use new libraries that, again, abstract away the difference between our environments. Something like the fetch library, isomorphic fetch. So then we could use that to start making API requests that, based on whether you're at the server or the client, it'll use a different service to be able to do it. OK. And now let's say we have a component, something like posts index. And it's in our blog, it's just going to display a list of posts based on the page that we're at. One way that we can start to encapsulate this information, right? We could say that on the component, it should know how to be able to fetch data. What's the information that it needs? So we can define a static function called fetch data that's going to take in the parameters of the router. And then we can run our API functions from here. So now, remember that function that we created, fetch all data? Here's what we can do. We'll pass it in the props. And then we'll go ahead and we'll define something like this. It's going to take all the components that are about to be rendered. It's going to filter and check that if the component has a fetch data function, we're just going to invoke it, and it'll run the API function that we need. On the backend, we're going to wait on it, because the backend should be much faster than the front end, and then provide all the initial data that it needs to render the full page. So that makes it work for the backend. But what if we're already on the client, and we're at one page, we're at /home, and we want to go to another page? We're no longer going to make a request to the backend, so we still need to be able to fetch data when we're on the front end. So what we can do is here, we can pass in a new property to the router called createElement. And what that's going to do is it's going to say, anytime we're changing the routes and you're creating a new component, check for the fetch data function and execute it. Because we're short on time, I'm going to skip past this one and skip past this one. And we'll ask the question, is it all rosy? Is it super easy? Should we just erase all of our code and start to write universal applications? But so why is it not really good? Because at the end of the day, there definitely is a difference between environments, right? Your Android, your server, and your client don't exactly have the same characteristics. So if you were to only develop on one, you may go faster initially. And there may not be a library that's going to help you. So you might have to start to write your own. But what are the trade-offs? What's the payoff? Well, we were considering this, right? 我们有 JavaScript, 我们有 Ruby. 可是我们也有 Android, 我们也有 iOS, 我们也有 virtual reality, 我们也有 Oculus. And we could, if we write declaratively, do this, right? And we can do this. So all of our code starts to become shared. And if we can do this, you can imagine all of your engineers going from the web to the server to your iOS app to virtual reality, and 80% of your code is shared. That's the dream that we're going for. If you write the code declaratively and you take the upfront cost, then it's easy to start to move the code around. You just need to change the implementation details. So I'm also going to skip past this one, and this one, and this one, and just say that if we're able to write code declaratively, that's the avenue that we can actually go ahead and start to share our code. And the benefits are enormous. And the second thing we need to do is to question assumptions. So we might ask ourselves, maybe you can't share the code between iOS and Android because they're too different. But let's find out. Let's not get lost because of pre-made assumptions. 谢谢你们。